Hello everyone. So today we are going to create a very basic load balancer in Go. I know we've all probably heard of a load balancer and the role it plays in distributing network traffic across multiple servers. So yes, today I decided to create one and understand how such load balancers work. So I've decided to go for the most basic algorithm, which is the round robin algorithm. So I decided to implement a very basic load balancer in Go so we understand the concept behind it and how it basically distributes the network traffic across multiple server instances. So yes, stay tuned and let's get into the video and see how it works.
Yes, so I wrote this blog post, a simple round robin load balancer in Go. I'll leave a link to this blog post in the description where you can go and check it out. So basically I explain what a load balancer is in the general context of a load balancer, as well as explain what a round robin load balancer is. That's what I implemented or decided to challenge myself to do. So I also wrote a blog post just with the basic implementation of what I was able to do so far. So yes, let's go into the code and see how I was able to do that. So this my project where I basically have my CMD folder which contains my main.go file. I have my internals where basically it's just my two structs, my load balancer struct and then my node server. So this will represent just the server instance in the network. So yes, my node server struct as well. So yes, let's try and simulate one of these servers. So I'm coming, I think I have, let me just drag it from here, put it right in here. So yes, I have this basic node server which we are going to use it to simulate what our server instance is going to look like. So we'll be making the request to this server via the load balancer, this load balancer. So we'll be making the request to this Node.js server through the Go load balancer. So this is just a very basic Node.js. So I basically have two files, my index and then my route. So in the route is just an Express app where it's a get request to this home route, then I send a response from the ports the server is running on, and in the index.js I just spin everything up here. So yeah, basically that is how it works. So let's go ahead and start these servers and then we can see how it how the round robin and everything just works. So let me open my terminal. So let me first create a very first instance. So I'll first export the port. I'll give this port 3000. Then I hit enter. Then I do node src index.mjs. Enter. We see server is up and running. So let's make a request to this to verify that yes, the server is up and running. So I come here, okay, I'll just select this, hit enter. I get my response, hello world from port 3000. So I open another terminal, I export the port again, port 3001. Let me name this 3001, hit enter. I do node source/index.mjs again. Server is up and running, this port 001. So I make another request. Let me copy this same URL, paste it here, change it to port 30001, hit enter. Yeah, get it, hello world from port 3001. Let's add one last one so we have at least 3 servers. So export import again 3002, hit enter. Node source/index.mjs. Enter. Server is up and running again. I create another new request. Basically just copy the same URL, paste it, change this to 3002, hit enter. Yes, I get hello world from port 3002. So yes, our server instances are running, our node server instances are running. Let's make a request from there. Let's make a request to these servers through the load balancer and we see how it goes. So yeah, let me go ahead and start this load balancer. So yeah, let me first explain inside the main.js. So when you see I've already registered those the instances as my server instance. So I have my server 1, which points to my localhost port 3000, server 2 localhost port 3001, server 3 then localhost port 3002. So yes, those are the servers we just spin up. So yeah, let me run this load balancer, then we see how it goes. So I do go run cmd/main.go, since my main file is in the cmd folder, hit enter. So that's actually running because I'm serving and I'm not actually logging anything, I'm just serving on port 8080. So I make a request. So here I make a request to port 8080. So 127.0.0.1 port 8080 /API /version1 /home. Yes, so I make a get request. So this is the path to our response. So this will be expecting a response from the Node.js servers on this endpoint, and this is the URL or the endpoint for the load balancer. So and this is the resource we are looking at, which is going to get forwarded to the node service we spin up. So yes, let's make this request and see what happens. So yes, I get my first response, which is from the server running on port 3000. Let's simulate another one and make another one. It gets forwarded to the 3001 server, make another one, gets forwarded to the 3002 server, make another one, it comes back to the 3000 server. So yes, that's basically how, that is a very simple implementation of how it works. Let's now go into the code and see how everything works together. Yes, so let me just stop the server. Let me close this and start from here. Let me close this as well. So yes, let me start from the internals, start from the node server, which is like the basic, so we'll build the understanding from there upwards. So yes, I have this node server struct, which basically I'm just defining the address and the port of that struct, of that server. And then I just initialize a new instance of that server. So I'm actually returning a copy of the server and not a reference to this node server struct. So I basically take in the address and then the port, which are both strings. Then I return the node server object. So I have these two methods on them, which is the server healthy. So basically here we will simulate and I get request to maybe, let's say, a health check endpoint on the server to get the status of the server, whether it's healthy or not, and then we return that status. So and then I have this method, which is the get address, where I basically just format the address and the port to give us the address of the server within the network. So yes, I come over to the load balancer struct, where I have my servers, which is a list of the node server. Basically this is going to act like our registry, where we basically store all the servers within the network, or the servers we need to make the request to. So this keeps track of those servers. Then we have our round robin number, which sort of keeps track of the server we sent a request to and the next one depending on the number this is. Then I have this mutex, which basically is a short form for mutual execution, so you can handle race conditions. Yes, so similarly to the how I'm returning in node server, I'm also doing the same thing for the load balancer, but in this case I'm returning the reference to this load balancer since it's just one instance of it, where I then update this instance with the service, then the round robin number I initialize it to 0, and then I initialize the mutex as well. So I have this very first method, which is get the next available server. So what it does is it just loops through all the servers here, and then get us the next server we're supposed to proceed the request to based on this particular number. So we can look at it as a list where we have server 1, server 2, server 3 all in the list. So yeah, I get a number of servers, which is the length of the servers list, and then I first log so that to prevent race conditions where let's say 2 requests are trying to access are trying to get the next request is already the next server. There can be an instance where we find out that 2 requests are sort of reading the same round robin number, which can then mess up the whole pattern. So yes, this sort of prevents those race conditions. So yeah, we look through the servers, get a server instance, get a current server instance based on the round robin number, and then use the modulo method to get the next server. So yeah, once we get a particular server, then we call the is server healthy method on it, which is this method, which we then make maybe an API request to get a health status of that server. So we call that method on the server instance that was gotten from the results of this, and then we check whether it's okay. If the server is healthy, we increase the round robin number to point to the next server, and then we return the server that was selected from the list of servers. So that's how we were able to get a 3001. So this round robin number is keeping track of. So when the round robin number is 0, it's going to point to the first, that's the initial index. That's the first server in the list, which is index 0. If it's 1, basically points to index 1, yes, and so on. So yeah, so it returns the server in that index, and then we now process the server. Sorry, now process the request to that server. Yes, so this is just a very basic, though we can make it more robust, but this is just like a basic implementation, so we get a concept of how everything works. And then we have this forward request method, which then proxies the request that is coming to this load balancer to the selected server from here. So basically what I'm doing is I first construct the address of the server we are going to proxy the request to. So since we are running locally, I'm using the HTTP protocol, where I format it with the get server address, which returns this get server address, which basically formats the address and then the ports together to give us a very single string as the address of the server. Basically do the same thing, so it gets us the ports, sorry, the address and then the ports and then the path, like I highlighted when we were simulating the request. That's the path to the resource, right? Then I create a new request with the http.newRequest method. So basically we just create a new request which takes in the method of the request, the URL, that's the address and the path of the server, and then the body from the request. So and then we get a request and then the error, so we check if there's no error, or if there's an error, we do something. So basically I'm just logging the error and logging this unable to create proxy request. Then I exit out of the function. So after making the request, we can now manipulate or copy the headers from the original request. From the original request, right? We can either copy the same thing, we can manipulate them, or we can cross-check the headers to make sure that we are not being attacked in any form. So we do all those manipulations or all those checks here, and then attach it to this request we created. So we cross-check the headers and attach the values of those headers to the request here, and then we now forward the request to the server. So we do that by creating this HTTP client struct, and then we in turn call the client.do, which, so let's read through what it says. Do sends an HTTP request and returns an HTTP response. Yes, so it then sends the request, which is this request we constructed, which has the method, the address, and the body. It sends, it proxies that request to that server, and then we get a response and then the error. So we cross-check again. If there's no error, we cross-check again. If there's an error, I basically log the error, just say this unable to proxy, unable to forward the request, and I exit out of the function as well. If there's then no error and it's successful, we get our response. This response, then basically we do the same thing. We cross-check, or we also manipulate the headers here and attach it to the response we are sending back to the client. So back to the original request that came in, we copy the headers again from the response to that request and send it back to the client, or we manipulate it on how we want to send it back to the client. We do the same thing as well. Then we write the status code to the request writer, sorry, the response writer object from the HTTP model, and then we copy the response body and attach it to, we copy the response body into the request, the response writer. I don't know why I keep saying request, the response writer, and then we send everything back to the client. So this is where we are able to get the message that's hello world from server, from port 3000. So this is where we copy that response body, and then we attach it to the original request, which is what we were able to see. I don't know if they'll still be there. Yes, that's just this. So that's the response body, which then gets copied to the response writer, and then we're able to see it as the response from our request we made. So yes, basically that's how I was able, yeah, I'm sorry I missed the main file. So when we go into the main file, basically I initialize each of those servers using the create the new node server instance, which is this. So I basically pass in the address and then the port, and then just return a node server. So that's what I just do for all three servers. So this is the address and this is the port. So for server 1, server 2, server 3, and then I now pass everything into the new load balancer, which is here, yeah, which takes a list of node servers and then initializes those servers here. So that's what I did, passing the list with server 1, server 2, server 3. And then we have this HTTP handle function. So handle function registers a handler for a given pattern. It handles an incoming HTTP request. So we use the slash, that's the home route where we get a response writer and then the request, and then I get the server. So I get a particular server to proxy the request to using the get next available server, which is this method, which loops through the servers and then gets me the next server it proxies to. So return the server, that's what we are returning, that's this node server we are returning. So it gives us back that server, and then I call the forward request method where I pass in the server then pass in the response writer and then the request. So this is the original request that hits our load balancer. So if you look at our forward request method, it takes in the server, the response writer, and then the request. So basically pass those in, and then the request then gets forwarded, the response then gets back here, and then it returns it back to the client, and then here I start the server. So yes, basically that's just a very basic implementation of how. So that's a very basic implementation of the round robin load balancer. I will leave a link to the GitHub in the project GitHub. I'll leave a link to the GitHub as well down in the description, as well as the blog post I wrote, which I sort of explained it much more into details. So yeah, this is just a brief overview of what I was able to do, and yeah, I will be looking forward to your comments and maybe pointing out where I may have made mistakes. Yes, so yeah, I'll be looking forward to that, and don't forget to leave a like as well as hit the subscribe button if you haven't, and then yeah, we'll see how my system architecture journey goes along on this channel. Yeah, thank you very much.